In section 5 of chapter 4, we're going to talk about scatter plots and then lines of best fit on the scatter plots. So by the end of this lesson, you should be able to do two things. You should be able to investigate relationships between quantities by using scatter plots, and then also using those lines of best fit to make and evaluate predictions. So in a scatter plot, we graph two sets of data, and we call this bivariate data, bi meaning two. A scatter plot shows the relationship between those two variables, and they're always graphed as ordered pairs. So whatever the two things are, you have your independent variable and then your dependent variable. And remember, this is your x and your y. Scatter plots are used to investigate relationships between two quantities. So we can draw conclusions. If we graph a bunch of ordered pairs and we notice something like this, this has a positive correlation, which means more of this means more of that. Where one like this, it has a negative correlation, because if we add more to whatever our x is, we're getting less with the y's. And then sometimes we just get random patterns here, and these things have no correlation. One doesn't increase as the other decreases. It's kind of all over the place. So for your first thing, you will have a graph. You will have to refer to it to determine whether it's positive, negative, or no correlation. And then if it's positive or negative, say what that means in this situation. So the first thing we're going to do is just notice the trend. This goes up. So we can say that this has a positive correlation. Now the second part of this, where it's asking us to describe what that means, that's when we need to look at the rest of the graph. Notice that this is talking about international travel. It has some years down here, and then it has the number of travelers here. So we can see that as the years progressed, as we increased here, we also increased the number of travelers. They both went up, and that's the positive correlation. So our description could say something like, as the years went on, the number of travelers increased. We could even get specific and say years after 1985, the number of travelers increased, but that's where you have to really recognize what the graph is about. So now we're going to go a step further and not only figure out what kind of correlation it has, but create an equation for a line that best fits the data. So scatter plots can show whether there is a trend in a set of data. When points all lie close to a line of fit or a trend line can model this trend. So here's your steps that you're going to follow. We're going to make a scatter plot first and determine whether a relationship exists. If it has no correlation, then we're done. Step 2, we're going to draw a line that seems to pass close to most of the data points. And then we're going to use points on the line to create an equation, just like we did in class today. And then we can use the line of fit to make predictions. So the first thing we're going to do is plot these points. So make a scatter plot. When we're making our scatter plot, we should label our graph and come up with a good way to break the graph up. So this shows the dollar value in millions for the sales of CDs for the year. Make a scatter plot and determine what relationship exists, if any. So the independent variable is the year, that's going down here. And now I'm not going to start at year 0 because CDs didn't exist in year 0, and they start with the year 2000, so that's a pretty good place to start. Year 2000. And then this will be 2001, 2002, 2003. We'll keep on counting. So we'll say after 2000. And then it's CD sales in millions. As I'm looking at this, it goes from 13,000 down to 5,000. So we could count by ones all the way up here. So 2, 4, 6, 8, 10, 12, 14, and this definitely fits on here. We could probably even jump one, but it's okay. And then remember, this is sales in millions. And now we can plot these points. So the first one is at 2013, 2, so somewhere around here. And then 2001 and 1209, 2002, a little more than 12, 2003 is about 11. Oops, this isn't in the right spot. We want about here. 2004 is about 11 again. It went a little up actually from the last one. 2005 was only about 10,000. 2006 was about 93. 2007 it went down to 74, so way down here. 2008 was about 54, so way down here. So we can see from this that there is a negative correlation. And we're going to see that when we create our equation because we should have a negative slope. Alright, so the next thing we have to do is we have to find a line that best fits this data. So what you want to do is draw a line that goes through a bunch of the points, as many points as possible, and it has a couple points above and a couple points below. So if I connect like the first and the last point, like these points here, if I was to draw a line like that, you don't need to draw this because I'm going to erase it in a second, we can see that almost all of our data points are above this line. So this isn't a very good line for us to pick. I would try picking one more like these 2 points, because then we have this line that has some of the points above it, like these ones, and some of the points below it. And I'm going to say that it goes through this point here and this point here. Those are the 2 points we're going to use to make this equation. So I picked the 2002 and the 2007. So just like any time I've given you 2 points and asked you to find the slope, we're going to do that with these 2. So I'm going to find the slope with the L. So draw the nice little L through it. And if I subtract that giant number on the top, the bottom's a little easier. We have 12,044 minus 7452. So we get 4592 divided by -5. We end up with a slope of about -918.4. So this is the slope of this line. Now remember, we need a slope and a y-intercept. So even though this data point goes through here, that's not really where my line went. So we can use point slope form, or we could use y equals mx plus b, whatever you like more. I'm going to use point slope form. These numbers get a little messy, but let's pick the 2002 point. So the y is the 1244. My slope's -918.4. And I'm going to subtract 2 there. So when I distribute, I end up with -918.4x plus 1836.8. And if I add the 1244 to both sides, we end up with y equals -918.4x plus 13,880.8. Now make sure that makes sense. If you look, it would go through about 13,880 right there. And this allows us to make some predictions like this next thing asks. So in lesson 4.2, we learned that linear extrapolation is used to predict values outside of the range of data. We can also use linear equations to predict values inside, and this is called linear interpolation. So this asks us to use the line of best fit that we just found to estimate the CD sales in 2015. Remember, this would be 15 years after 2000, so we're going to plug in 15 for x. So my equation is this y equals negative 918.4x plus 13,880.8. And all we're going to do is plug in the 15 and see what we get out. And then this just becomes a calculator problem. So we should expect a low number because if you look at the graph, the CD sales are going down. And when we subtract, we end up with a negative number. Negative 104.8 is our Y value. So in this case, that's telling us that after 15 years, no one's really buying CDs, which is kind of true. So you have some to do on your own. Make sure you write down any questions you have, and we can go over them in class. Enjoy your night.